We're going to go over the 8.3 homework. So you need to have your 8.3 homework out, and it would also be helpful to have your book open to page 476 to 479. We're going to start with number 10. And number 10 is similar to number 8 and 9. Use the information given to list all pairs of congruent angles and write the statement of proportionality for the figures. This was covered in the homework examples. The first thing we're going to do is look at the similarity statement. And this similarity statement has this single squiggle mark in the middle. This is a similar symbol. It's like the top of a congruent symbol. And we're going to go through and list all the pairs of congruent angles. So this is like what we talked about with congruent triangles and how the corresponding parts are in the same position. It works the same way with similar figures. Remember, similar figures are the same shape, but they're different sizes. So the corresponding parts in the same position are going to be your congruent angles. So we're going to have angle Q will be congruent to angle A. And the reason the angles are congruent is because that gives them the same shape. The lengths of the sides are proportional. They're different sizes. Angle R then is the second letter, so that'll be congruent to angle B. Angle S is the third letter, so that's congruent to angle C. Angle T is the fourth letter, so that's congruent to angle D. And angle U is the fifth letter, so that's congruent to angle E. And you could have listed them with QRSTU first and then the ABCDE, or you could have listed it angle A is congruent to angle Q. So these are congruent angles because the congruent angles is what gives the similar figures the same shape. The statement of proportionality is about the sides. The sides are different lengths because the shapes are different sizes, even though they're the same shape. But what happens is if you take those corresponding sides and you put them into a fraction, and you do that with all the corresponding sides, all the fractions will be equal. And we know that a fraction or a ratio equal to another fraction is what makes a proportion. So we're going to take our first side. Our first side would be QR. And I'm going to put that in a fraction with the corresponding side from our figure ABCDE. So since QR is the first and second letter, AB is the first and second letter. If you were stuck on this, you could have drawn a pentagon and labeled it QRSTU. And you could have drawn another pentagon, same shape, different size, and labeled it in the same order, ABCDE, so that you could look and see QR and AB are the sides that are going to be in the same fraction. Now, since I put QR on top, for all of my statement of proportionality, sides from QRSTU must be on top. So my next side, I'm going to use the second and third letter, RS. That corresponds to second and third letter, BC. And if we put these in fractions, remember, all of those fractions will be equal. So we're going to continue on. We did RS, so then I'm going to go ST. ST will go with CD. The fourth and fifth letters, TU. TU goes with DE. And then I can't forget the side that connects the first letter with the last letter. So QU goes with AE. Make sure all of these top letters come from the same figure. They're all from QRSTU. All the bottom letters come from the same figure, ABCDE. So when you're listing pairs of congruent angles and the statement of proportionality, this first part, those are your pairs of congruent angles. You must have the second part. That's also the statement. That's the statement of proportionality. When you get into section 8.4, which we'll talk about in a few minutes, numbers 9, 10, and 11 says list all pairs of congruent angles and write the statement of proportionality. So same thing when you start 8.4, you're going to be working the same kind of problem. Back to 8.3, number 11. Decide whether the quadrilaterals are similar and explain your reasoning. So they gave you the four pictures, and number 11 talks about quadrilateral ABCD and quadrilateral FGHE. So I have those figures drawn. What we're going to look at is we're going to look to see if they're similar. They should have congruent angles and proportional sides. So if I look at figure ABCD, all four angles are right angles. So I need to see if that's true with figure FGHI. So if I look at this second figure, FGHI, I have one right angle. But in this, I know that it's quadrilateral, and I also know that these sides are parallel. And we know between any two parallel lines, these two angles must add up to 180. So if F is 90, then G is 90. The same thing happens using our parallel sides F, G, and EH. This H is 90, and using the same parallel lines, E is 90. So first of all of the angles are congruent. So the figures could be similar, but we need to check the sides. We need to make sure that the sides are proportional. And we want to make sure that we create those fractions like we did for our statement of proportionality in the same order. So if I use side DC on top and BC on bottom, and I divide those, 7 divided by 3.5 is 2. The side that corresponds to DC, DC is fourth and third letters, DEH. Side EH is 4. The side that corresponds to BC, BC is the same as GH, and side GH is 2. 4 divided by 2 is 2. And I knew that I could bring this 4 over because we have our 4 right angles and our both pairs of opposite sides parallel. That's going to be a rectangle, so the sides are congruent. Since these reduce to the same amount, then yes, these are similar. And it says explain your reasoning. So I'm going to say all angles are congruent. I'm going to use my congruent symbol. And all sides are proportional. They reduce to the same amount. You could also say something like AB over FG. You could write out that statement of proportionality equals BC over GH equals CD over HE, CD over HE equals AD over FE, just using the ones that are corresponding, and they all reduce to 7 over 4 if you put those sides in that way. Or you could use the same sides of the rectangle like we did and end up with the 2. So yes, those are similar. 19 through 23, we have questions on different parts of this, so I kind of want to run through all of these problems, all 5 of them, and talk about the scale factor. Scale factor is really, really, really important, and you need to know scale factor for the test. 19 through 23 says using similar polygons. Quadrilateral PQRS is similar to, that's that single squiggle. This is a similar to symbol. So it's similar to JKLM, and I've drawn the pictures. Number 19 says find the scale factor. You get a scale factor by taking corresponding sides and putting them into a ratio, putting them into a fraction, and reducing it. That's the scale factor. However, be really careful with the order. 19 of PQRS to JKLM. Since PQRS is first, we talked about you're creating those problems. That's the top part of the fraction. The 2 is your fraction bar. JKLM is going to go on bottom. So I'm going to look at my figures, and I'm trying to find a pair of corresponding sides that I have numbers for both. So, for example, if I try to use JK, JK corresponds to PQ, and I don't have numbers for both of those. So if I look, the ones I have numbers for both would be KL and QR, but I want to watch the order. Since PQRS is listed first, the 12 must go on top. JKLM is listed second, the 15 must go on bottom. Then we're going to reduce by finding something we can divide both of those by. I can divide by 3, and I get 4 over 5, or you could write it 4 to 5 using your colon. Either one is an acceptable answer. So the number 20 also asks you about a scale factor, but they switch the order. This one's the scale factor of JKLM to PQRS. JKLM is first, so that side must go on top. So this time I'm going to put the 15 on top. PQRS is second, so the 12 goes on bottom. So the scale factor of JKLM to PQRS is 5 to 4, or you could write it 5 to 4 with the colon. Really watch the order of the scale factor, because if it's in the wrong order, it's going to be incorrect. 21 says find the values of W, X, and Y. To do this, we're actually going to use that scale factor, 21, and I'm just going to set up the first one, and then you can go through and solve the other two. So let's set up W. If I'm going to find W, I need 4 pieces of these similar figures. I need a pair of corresponding sides, so 2 sides, that both have numbers. So the ones that we use for the scale factor, the 15 and the 12, but we can actually use the scale factor. So I'm just going to keep this 4 to 5 equals. Then I'm going to find the side that uses W, which is PQ, and its corresponding side, which is the 25. Now, since I have 4 over 5, that's when we use the 12 on top and the 15 on bottom. So then W goes on top and 25 goes on bottom. You're using a pair of sides where you have both the numbers, and you could have used the 12 over 15 instead of 4 over 5, and then a pair of sides that has the letter you're trying to solve for, so the W and the 25. These two tops, the 4 and the W, have to come from the same figure. That was the 12 and the W before we reduced the 12 and 15. The bottoms, the 5 and 25, came from the same figure. The 4 and 5, the first fraction, those are corresponding parts. The W and 25, those are corresponding parts. So there's a relationship in here. To solve a proportion, you guys have told me we're going to cross multiply. So 5 times W is 5W equals 4 times 25 is 100. And then if we divide, we get W is 20. Go through and solve for X and Y the same way. And again, you can use the 12 and the 15, but it's so much easier to use the 4 over 5 or the 5 over 4, the reduced one. Keep these in the same order. Since I did 4 over 5, that's the 12 over the 15, W over 25. Number 22, find the perimeter of each polygon. Once you've found X and Y, go through and add up all the sides. Then it says find the ratio, for 23, find the ratio of the perimeter of PQRS to the perimeter of JKLM. You're doing what turns out to be a scale factor. You're going to find both perimeters. PQRS is listed first, so that goes on top. JKLM is listed second, that goes on bottom. And you reduce that, you're going to find something about the ratio of the perimeters and how it relates to the scale factor. So go through, pause the video, finish that problem, figure out X and Y, find your perimeters. 31 through 38 I want to talk about because it's so much easier if you draw a picture on these. Tell whether the polygons are always, sometimes, or never similar. So let's just pick a couple of these. 31, 2 isosceles triangles. So I'm thinking about an isosceles triangle, and I'm thinking about these two sides being congruent, which means these angles are the same. I could have these two sides are the same, and I could have these angles at the bottom the same as the first two. So then, yes, that's similar, but they don't have to be the same. I mean, these guys could be like an 80 and an 80. And then if I have a completely different isosceles triangle, this could be like a 65 and a 65. Or I could have one that's equilateral. That's a type of isosceles. So it could make it so it's congruent, but it doesn't always have to be. And that's really what you want to do with these. Go through and see if you can make it congruent, and then go through and see if you can make it not congruent. 32, 2 regular polygons. Okay, so regular means all the sides are the same, all the angles are the same in the figure. So if I have a regular pentagon, and I wanted to think about the degree measure of the angles. Well, I know to find the degree measure of an angle in a pentagon, I'm going to do 180 times 5 minus 2 over 5. So I get 180 times 3. So I get 540 divided by 5. And I remember that one of these is 108. So all of these angles, and even if you didn't solve this, you know if it's regular, all of these are the same. So all of these are 108. Now, if I had another regular pentagon, those are all 108. And because all those angles are the same in the bigger pentagon as the smaller one, they're going to be similar. But it didn't say it had to be a pentagon. It just said a regular polygon. Well, I could draw a different regular polygon. I could draw a regular quadrilateral. That would be a square. Those are not similar. So again, this is a sometimes. See if you can make it true. See if you can make it not true. Let's work on 35, 2 squares. I'm going to draw a square. I know however long this side is, those sides are the same. The angles are 90. I'm going to draw a different square. All these sides are the same as each other. They're different than the sides of the first square because if we're trying to see if they're similar, remember they have different sizes. But all the angles are the same. All the angles are still 90. So those are always similar because all the angles are always going to be the same. Even if the sides in the first square were the same as the second one, if they're the same size and they're congruent squares, that's a type of similar. Let's try number 36. An isosceles triangle and a scalene triangle. Okay, so an isosceles triangle, I have two sides that are the same, so I have two angles that are the same. But in a scalene triangle, none of my angles can be the same. So I'm not going to have congruent angles. Those are never going to be similar. So you're drawing the figures. You're trying to see do they have congruent angles. The angles are the same, but the side lengths are different. They're proportional. See if you can make it happen. See if you can make one that's not true. Those turn into sometimes, or is it always true like the squares? Just a quick note, 53 to 58, finding slope. Please remember that it's wise guys over x-men, y minus y over x minus x. Whatever y you start with, you have to start with this partner x on bottom. Really watch those negative signs. 53, you should get 1. 54, you should get negative 2/3, and you could have had 2 over negative 3. It's the same thing. Really watch those negative signs. So you may want to just go through and finish those slope problems. Double check those with someone close to you. See if you guys got the same slope. Okay, if you need to pause, finish up 8.3, that's fine. At this point, I'm going to move on to section 8.4, which was assigned yesterday. So in section 8.4, page 483 to 487, again, it will be very helpful to have your book open. 9 through 26, 39 to 44, 61 to 71. Let's start with 12 through 17. You have a diagram similar to this from the book, and it says use the diagram to complete the following. Number 12, triangle PQR is similar to triangle blank. And I want to keep this in the same order. So if I go PQR, watch these angles. You're going from P, not marked, to Q, single mark, to R, double mark. So I'm going unmarked, single, double. Same order. Unmarked, single, double. So LMN. Keep those corresponding parts the same, just like we did back in first half geometry when we talked about congruent triangles. 13 is a statement of proportionality, just like we talked about at the beginning of 8.3. Go through and fill in those parts. 14. 14 gives you a proportion. You have a 20 on top as your first extreme, top left, and a 12 as your other extreme, bottom right, and you're filling in the pieces. So if I look at 14, the 20 on top is QR, and the 12 on bottom is from the other triangle. So it looks like I'm putting pieces of PQR on top and pieces of LMN on bottom. So on bottom of the 20, I want the side that corresponds to QR. Okay, so the 20 is here, and that's QR. And since that 12 is on bottom, I know we're putting sides from the small triangle on bottom. So corresponding to QR between the single mark and the double mark is this 15, between the single mark and the double mark. Now the 12 is from the small triangle. So on top in this space, I need a side from the large triangle. So I'm looking for someone that corresponds to LM, to the 12, and that's going to be Y. Now when you fill in 14 and 15, hold on to those because 16 and 17 has you solve this. So when you get down to 16, you're going to cross multiply and divide to solve the proportion. When you write the proportion for 15, you solve that for 17. Okay, lots of problems similar to number 21. The directions for 18 through 26 say determine whether the triangles can be proved similar. If they are similar, write a similarity statement. If they are not similar, explain why. So I'm looking to see that the angles are congruent. And remember, we talked about angle-angle similarity postulate. You don't have to show all three. If two pairs of angles are congruent, the third ones have to be. And again, you want those sides to be proportional if we have that information. So we'll look through these angles. But if you have those angles congruent, we said that is enough to make the triangles similar if you have the two pairs of angles. So for example, a lot of these pictures you don't have the sides. Let's stop and look at those angles. So I noticed in 21, we have a 48 at X and 48 at G. Okay, there's one pair of angles. I have to find a second pair. Y is 77. That's not the same as H, but I'm missing the third angle of my triangle. So what I'm going to do is I'm going to use the fact that I know a triangle adds up to 180 and find the third angle. So I'm going to add 48 and 77 and get 125. And then if we do 180 minus 125, we get 55 degrees. So D is 55. Well, if 48, 77, and 55 make a 180, look, 48, 55 at G and H, this is going to be 77. And even without the 77, we're looking for two pairs of congruent angles. So the 48s are the same, 55s are the same. These triangles are similar because of angle-angle similarity. So if you're asked for a reason, we're going to put A similarity, angle-angle similarity. This problem didn't ask for a reason. It said to write a similarity statement. So we're going to say, yes, these are similar. And this is kind of like your congruent statement where you talk about the triangles. So we're going to do the first triangle is similar to the second one, and we have to keep the letters in the same order. So for this first triangle, I'm going to do triangle X, Y, Z. So I went 48 degrees, 77, 55. The other one has to be in the same order. X, the 48, corresponds to G. Y, the 77, corresponds to F. And Z, the 55, corresponds to H. That's a similarity statement. Be careful, we talked about a proportionality statement, which is all the fractions equal to each other. This is a similarity statement, and you need to be comfortable writing these. Again, if I was asked for a reason, why are these triangles congruent? Angle, angle, similarity. And when you write that reason, it's angle, angle, similarity. Again, we have to for this problem, but I want to keep talking about those because you'll be required to do that next week for the test. A couple tricky ones in this section, 18 through 26. Look over at number 24. And again, have your book open to page 484 because my picture isn't exactly like the one in the book. Number 24, you have what kind of looks like one of our triangles from our congruence pages that we used to do in first half, but the bottom kicked in. What's actually happening here is you have this first triangle and you have this second triangle. Now, because part where C is a straight line and there's a 90 on the left side, I know this part's 90. So now we're trying to see if those two triangles, the big one and the little one that I've outlined in red and blue, are similar. I know I have 90 degrees in each triangle, and I have a 50 in each triangle. So yes, these are similar. If I was asked for a reason, it would be angle, angle, similarity, AA, and the similar symbol. It didn't ask me for a reason, it asked me for a similarity statement. So triangle, and I'm going to name the red one first, triangle ABC, is similar to triangle, and it has to be in the same order. So if I start with A was the 50 degrees, E is 50 degrees. B is in the middle, that didn't have an angle, so D didn't have an angle. C is at the end, that's the 90, so C. And this is our similarity statement. Triangle ABC is similar to triangle EDC. And I'm going to erase my D and rewrite it because it kind of looks like a triangle symbol. There we go. Okay, same section, number 25. Be careful with this picture because what's actually happening is you have a small triangle here and you have a large triangle here. And it will help you to separate these pictures a lot of the time. Okay, so the first thing I notice is they're overlapping, which means if I put a mark at the top at this angle, that's the same as the top angle of the other triangle, the large one. So this top angle for the red triangle is the same as the top angle for the blue one. So right there I have one pair of congruent angles, and we're looking for two, angle similarity. I need two pairs of congruent angles. The only other thing they gave me is that these sides are parallel. So let's go back and look at parallel lines. So these are my parallel sides. This is Y, Z, W, X. And have the side of the triangle that comes through and works like your transversal. You have these corresponding angles. So I have that W is the same as Y. These angles are the same. You could have also done the same thing on the other side at Z and X. So this YZ and this angle X are the same. So I can actually prove that all three angles are congruent. So yes, these are congruent, or sorry, not congruent, similar. My angle similarity. I need to write my similarity statement. So I'm going to look at my red triangle. I'm going to call this VYZ, triangle VYZ. It is similar, make sure you're using a similar symbol, to V in the red triangle is the same as V in the blue. Y in the red triangle corresponds to W in the blue. Z in the red triangle corresponds to X in the blue. So it helps a lot to take these apart. Don't forget about those corresponding angles with our parallel lines. Okay, number 26. Let's go to the last one in this section. Kind of like 24 and 25. There's two triangles here. One's inside of the other one. So I'm going to outline the small triangle in red. And there's this large blue triangle. Okay, the first thing I notice is that angle Q and angle S are the same. So there's one pair of angles. The other thing that's happening is if you look at these triangles, this angle P in the red triangle is the same as angle P in the blue triangle. So I have two pairs of congruent angles, which is enough because of angle-angle similarity to say the triangles are similar. Let's start with the small red one. I'm going to call this triangle PST. That is similar to triangle, now it starts with P. Angle P is the same for both triangles, so we'll start with P. In the small red triangle, we went to S. That has a single arc. That's the same as Q in the blue one. T was the remaining angle. R is the remaining angle. Okay, make sure you write those similarity statements. 39 says the triangles are similar. Find the value of the variable. So this is just setting up a proportion. They told us the triangles are similar. They marked the two pairs of angles. We're going to set up a proportion. And there are multiple ways to do this. One thing you can do is use two sides from the same triangle. So if I look at the larger triangle, I do P over 16. Then the second fraction is all about the small triangle. P, which is on top, was between the marked angles. So I'm going to put 7 between the marked angles on top. 16 on the right was on bottom, so I'm going to put the 8 on bottom. Cross multiply to solve. P times 8 is 8P. 16 times 7 is 112. And if we divide by 8, P is 14. Now, that's not the only way to solve this. You could also use corresponding sides. You could say I'm going to put P on top. The side that corresponds to that on bottom is 7. So you're doing big triangle over little triangle. Same thing in the second fraction. I'm going to do big triangle over little triangle. 16 over 8. This 16 over 8 reduces. And if you can reduce that, please do. It's going to make the problem easier. So 8 divided by 8 is 1. 16 divided by 8 is 2. We'll cross multiply to solve. P times 1 is 1P, which is P, equals 7 times 2 is 14. And we're done. You can set that up either way. There should be a relationship of your proportion. So look at the first one, for example. This fraction is all about the big triangle. The second fraction is all about the small one. The tops, P and 7 are corresponding, 16 and 8 are corresponding. The same kind of thing happens the second way we set it up. P and 16 both on top are from the big, 7 and 8 both on bottom are from the small, and then you put your corresponding sides and fractions. Please set it up the way that makes the most sense to you, because then you're going to get these problems correct. Two tricky ones I want to talk about, and then we'll be done. Number 44, be careful, because when you go to set this up, this bottom letter is an S. Be careful because you need to put the sides from your small triangle, which is the red one, and the big triangle, blue. So if I look at the small red triangle and I want to do left side over bottom, 4 over 6. Then when I go to do my other fraction, I'm looking at the large triangle. I want to do left side over bottom. But how much is the left side of the big triangle? We're going to have to add those up. So 4 plus 5 is 9 over the bottom is s. We'll cross multiply. 4 times s is 4s. 6 times 9 is 54. If we divide by 4, we will get that s is going to be 13.5 or 13.5. And that is absolutely fine. In this section, 40 and 44 come out as fractions. Number 40 and number 44 both come out as fractions. Over in the review part, 66 through 71 is just solving proportions, which we've been doing for a few sections now. I wanted to stop and look at number 71. We're going to cross multiply to solve, so we'll multiply 8 times 32, and we'll multiply x times x. And you can write down whichever one you want first. So I'm going to do x times x. Remember, when we multiply those same variables, the same base, we add up the exponents. So we get x squared equals 8 times 32 is 256. We've done a couple problems like this. We've talked about that to get rid of the squared on the x, we need to do its opposite. To undo a squared, we do the square root. So I'm going to square root the left side and the right side. Squared and square root cancel, so we get x equals, and the square root of 256 is 16. This is the one time that we do actually need to go back and think about the principal and the negative square roots. And we keep talking about in geometry, we're doing length, so we don't use that negative root. However, for a problem like this, the negative 16 would also work. So there are a few applications in geometry where we still use this, where if we plugged in the negative, we get a negative 1/2 on the left and the right of the equal sign. Okay, so that's questions from 8.3, 8.4. Use those to kind of go back. Make sure you have that homework finished. Work on your 8.5 and take your 8.6 out.